Hello everyone. She's a beautiful thing, that pancake coil, when the light's sitting behind it. But that's not in this video, other than to block the super bright light. What I'm going to show in this video is going to be the poor man's version of doing things. The current setup that I'm using, don't stress, I understand this looks difficult and hard to reverse engineer, so schematics, like always, at the end of the video. So there's a couple of poor man's things I want to display, rather than talk about what's going where here. So the first one I want to discuss is using bulbs, light bulbs, as resistors. These the neon little bulb that's glowing there, it's very hard to get a good shot of that. You can see a little bit of discoloration there, where it's going black on the inside, and that's basically too high voltages being placed across that neon bulb, and it starts to burn and therefore reduces its lifespan. So I'll put on the screen something we can see, because it's just too difficult. I tried to get even a photo of those is quite difficult. But I'll put on the screen because it's important that we understand what's going on with these things. They are a non-polarized, so it's a bit funny to call it a DC device because it's not polarized, but the official definition of what those neons are is a non-polarized DC device. It has two symmetrical elements or electrodes, and when DC is applied, you can see the one on left of screen at the moment, the left leg of that, you can see down the bottom, has a positive sign, indicating that the one that glows in this case determines the negative side. Now when a charge is applied to these, one of those elements, a DC charge anyway, one of those elements will glow and the other one won't. And that's how you determine what's going across them in a DC state. In the AC state, which you can see on the right hand side, both electrodes will glow. So in the case of MTech, using those neons to separate, so they're not actually a direct connection, they are connected through the ionized gas, as far as I understand it. I could be wrong, but they're a means of isolating what can be a very, very high voltage signal that interferes with the operation of most coils. Example, if the device you're using senses a really, really high voltage that's being produced by these radiant circuits, then it may not charge, or it may not see the battery that it's trying to go into at all, because of the excessively high voltage throughout the system. So it's important to have the right resistor value on these things, and they typically come with a resistor on them. What they're intended for normally is as a indicator light. So I got those ones from a rice cooker, the ones that I'm using. An old rice cooker died, $10 rice cooker, and it had two in there, one for the hot side and one for the warming side indicator. So when that died, I extracted those, and I just purchased myself a bag of 50 of them with the correct resistor, and that's something that they really can't operate without. You'll burn them out so fast. And they're only a 90 volt item, so I think that, yeah, they come with a 50k to, well, anywhere up to, depends on what voltage you put in. So for 110 volt AC, they would put anywhere from 50k to 200, 250k ohm resistor, and then for 240 volt, I think they have it'd be double that. So anywhere from 100k up to 400 is probably a standard value resistor. So Don Smith was always talking about bulbs, and Don Smith was very he wouldn't often get straight to the point. I don't believe he was legally allowed to. I think Don Smith had been bought and wasn't allowed to say some things. But if you watch closely, he would tend to say something, and everyone would be off track in their mind somewhere else, and then he would just smile or smirk and change the subject, and hang on. It's important to read between the lines with these guys. They never came straight out and just told the truth. But Don Smith talks about using resistors, and resistors being the key to allowing this type of energy to be fed back to the system. So and that bulb there is a 7 watt, 7 watt, 240 volt, small incandescent bulb. So very cheap to buy, hard to find, or harder to find than they used to be. But that has a resistance of 580 kilo ohms. So when that LED, that neon LED for a 240 volt system, is meant to have on it, say on average 1k resistor, and you put on a 580k bulb, resistance in the form of that bulb, and that's the reason why we're getting a little bit of black on there. There's a little bit too much voltage being seen by the neon because of the bulb. But I like to try and get close to the correct value, and then I'll add on a pot. So I got this 10k pot here. It's currently maxed out, and on the 10k, so we're looking at 580, 590. I'd probably say 600k resistor would be perfect for those neons to be fed back to the battery. Again, don't stress. I'm going to have all of it on the schematic. So yeah, that's the poor man's, and we can wind this pot, and we can see a small variation in energy going through that bulb. It's easier on the naked eye. It's easier if I turn it fast. You can sort of see fluctuations. You can definitely see fluctuations on the big bulb. And it's a case of getting that to the sweet spot where it's super bright, and that will recharge. Sometimes it will recharge that battery. It was climbing. It started at 59 and was climbing, but if you make an adjustment like that, you're going to have to get back to that sweet spot before it starts charging. Just needs to be the exact correct amount of resistance. So you need to grab some varied bulbs, and so this one here, gotta be careful where I put my hand. This one here, I think it was 330K. This one, the little one that I'm using down there, was the 580K. And then this normal 70, I think it's like a 72 watt, 72 watt halogen bulb only has 55 ohms. So you will have to experiment with different bulbs and try and find the one that puts the right voltage. Now, what's important here is this bright light is running from the capacitor, so the light is in series. Again, it'll be on the schematics. The light is in series with the battery, so it's that light then connects to this bulb, which is acting connects to the pot first, and that gives me that variable ability there. So pot, then it goes to the bulb, then it goes to the neon, and the neon allows it to separate from the rest of the circuit in that non-polarized sense, but obviously power is still going through it. So keep in mind, remember that little image we saw earlier, that one side glows, and that indicates the positive side in a DC form. If both sides are glowing, then it's a fair chance that AC is going through your system. And when you consider that light is an AC 240 volt AC, I think that's a 9 watt LED bulb, just straight off the shelf, no mods. So the next poor man's thing that I'd like to show you is a poor man's spark gap. Now, if I reduce the resistance on this pot, and we have a look over here, got to be careful not to get the camera too close, but if it can focus down there, that there, and I just adjust that pot to allow that to light up. But that's a poor man's spark gap. That is a sealed glass tube, and you can see the plasma in there. And if I change that resistance on that pot that we saw that feeds back to the battery, that will engage or disengage. And the camera's acting a bit weird after taking it close to that circuit. That's probably not good. Okay, so I'll turn that off so we can I'll turn the circuit off so we can get a better look at that. But that is got to be the cheapest spark gap you would ever find. Just turn that circuit off. And then we get the same function here after the circuit's off until the capacitor has drained. We have power going back from that capacitor through the light, through the neon, starts flashing there as it runs out, and it's sort of acting like a cap dump in a sense, because it isn't connected until a high enough voltage is obtained. So you can also use those for cap dumps. Be respectful of its voltage thresholds, otherwise you'll end up with a blackened bulb like that, and it won't last as long. But as I said, this is just experimentation phase, so unfortunately there's a few things that will be sacrificed. RIP to the 2 transistors I killed this morning. So let's have a closer look at that. I'll take it out of circuit, and then we can get a better look at it. Now be careful because it has a capacitor of its own. This is a fluorescent light bulb starter mechanism. There is virtually nothing to it. It's an old school spark gap. Capacitor on the back, and they go inside those little cases, and you'll just see, normally you just see the ends there sticking out. Okay, but very, very cheap. They're made for starting fluorescent light bulbs. So that's how she looks normally. You can get them in many different brands, usually come 2 in a packet. Those are the cheap light bulbs that I got. 7 watt E14. Says on the back 240 volt 7 watt. The other ones just standard light bulbs. Yeah, pretty straightforward. But if you don't have the money to go, buying expensive spark gap generators, and do they make a difference? Yeah, they do. You don't need them. Like for example, my circuit will operate just fine without spark gaps. But if you want to enhance that rechargeability, a spark gap is great. And there's sort of a spark gap going on in the neons anyway. But it just allows you to fine-tune this a little bit differently. That poor man's spark gap is in line, in series with my high voltage output that runs to earth. We'll turn the circuit back on. Light comes on. So we can go for a reduced, where's that resistance? I'll just put that resistance back to the sweet spot. You can do that a couple of ways. You can do it by watching the brightness. You can also do it by seeing the immediate drain on the battery. It's hard to measure what's going back through these systems because most meters just don't know what the crap's going on. We've still got the same old wireless, nice wireless effects, and here we go, this one here, that is just 4 green LEDs in a circle, which in essence becomes a Stifler's loop, where I just put my finger on that anywhere in that loop. That's not connected to anything, it's just sitting on the battery. So there are many ways that we can get this energy. I can connect my homemade capacitor to those LEDs. There we go, and they just stay on by themselves. If I was to give them a proper earth, then they would glow nice and bright like that all the time, and they're not even connected to. Actually, we'll take them and we'll move them over here, and we'll very carefully sit that there, and I will rest them on the same earth that is feeding the Avraменko plug. But there you go. What's powering that? I wouldn't have a clue. Well, I do actually, but I don't want to go down that rabbit hole. All right. Thanks for watching. Please like, share, subscribe. If you're not sure what's going on, please check out my other videos. I'm starting to realize a lot of people come in and go, what's going on here? That's a whole big mess of wires. So please go back and check out the other videos. They're really important. and it will give you a clear understanding of what's going on. So just to summarize, we looked at the poor man's resistor, if you can't afford resistors, and we looked at the poor man's spark gap. Change the resistance and the spark gap goes out, change it back, and we have spark gap again. Alright, thanks for watching. Please like, share, subscribe. Have a nice day.